Hello and welcome to day 4 of our low-level design course. Today we embark on an essential journey, one that introduces us to a developer's toolbox of timeless solutions, design patterns. These are not just academic concepts, they are living, breathing techniques used daily by engineers at companies like Google, Amazon and Netflix. Whether you are building a small CLI app or architecting a large-scale system, design patterns provide a structured way to solve problems elegantly and efficiently. Let's dive in. Before we go any further, we need to answer the fundamental question: what exactly are design patterns? Simply put, they are proven solutions to recurring design problems, templates that help us structure code in a clean, reusable way. They are not lines of code you can copy paste, they are conceptual building blocks. Design patterns were popularized by the Gang of Four, a group of software engineers who documented these patterns in a landmark book back in 1994. The goal: to empower developers with strategies that have stood the test of time. Once you learn to spot these patterns, you will start seeing them everywhere in libraries, frameworks, and open source tools. You might be wondering, why do I need patterns if I can just write custom logic? Good question. Design patterns bring standardization and predictability. They reduce the time you spend reinventing the wheel. They help prevent bugs by offering tried and tested approaches. They also enable better collaboration. When you say, let's use the strategy pattern, your teammate knows exactly what you mean. No need to explain from scratch. In a nutshell, patterns are like shared wisdom. They make your designs smarter, your code cleaner, and your team stronger. Design patterns are broadly classified into three categories. First, creational patterns, which deal with object instantiation. They help decouple the creation logic from usage, giving you more control and flexibility. Second, structural patterns. These are about composition, how different parts of your code relate and work together. They improve maintainability by structuring code in neat, scalable ways. And finally, behavioral patterns. These are all about communication. How does one object interact with another? Who knows what and when? Together, these categories cover the core concerns of software design: creating, connecting, and communicating. Creational patterns focus on how objects are created. Instead of calling constructors everywhere, we use patterns that control object creation logic, which can help us enforce consistency, flexibility, or performance. Examples include the singleton, which ensures a class has only one instance, useful for things like configuration or logging. The factory method, which creates objects without exposing instantiation logic to the client. The builder pattern, which lets us construct complex objects step by step. Use creational patterns when object construction is complex or when you want to abstract away dependencies. Structural patterns are like architectural blueprints. They help you compose classes and objects to form larger structures, all without losing flexibility. For example, adapter helps you connect incompatible interfaces like plugging a USB into an HDMI port. Decorator lets you dynamically add behavior to an object. Think of it like dressing up your coffee with milk, sugar, or caramel. Facade provides a simplified interface to a more complex system, just like how your TV remote hides the internal circuitry. If your system is becoming messy or too tightly coupled, structural patterns can clear things up. Behavioral patterns focus on how objects communicate and behave. They help distribute responsibility in a flexible and dynamic way, a key to achieving low coupling and high cohesion. Some examples include strategy, which lets you define a family of algorithms and switch between them at runtime, like choosing between different sorting methods. Observer, where objects subscribe to events and react when changes happen, perfect for event-driven systems. Command, which turns requests into standalone objects, enabling undo, redo, and queuing. Behavioral patterns make your code more adaptive to change and easier to maintain. Let's take a moment to connect these patterns to the real world. Design patterns can sound abstract at first, but they are everywhere around us. For instance, a singleton is like your system's configuration manager. There's only one and it's shared globally. A factory is like a restaurant kitchen. You place an order and the kitchen prepares it based on input. You don't care how it's done. A decorator, think of it as customizing your drink. Base coffee plus add-ons like milk, cream, and flavor shots. And the observer pattern is like YouTube subscriptions. You get notified when your favorite creator uploads a new video. Using analogies helps us internalize these abstract ideas more naturally. Now let's talk about when to use patterns. Patterns shine when you recognize a recurring structural or behavioral problem. They are also helpful when you want your code to be extensible, when you anticipate future change. But be aware, patterns aren't silver bullets. Avoid over engineering. Don't use patterns just to sound smart in code reviews. Sometimes a simple class does the job better than a complex pattern. Speaking of caution, let's touch on anti-patterns. These are common traps developers fall into when misusing patterns or ignoring good design. The God object, for example, is a class that tries to do everything, leading to bloated, unreadable code. Spaghetti code refers to unstructured logic that's tanged and hard to maintain. And overusing singleton can make your code rigid and hard to test. The key takeaways: use design patterns mindfully. They are tools, not trophies. Let's make this hands-on. You will be presented with short, real-world scenarios and asked to choose the most appropriate patterns. For instance, if you want to allow user to switch payment methods at runtime, you are looking at the strategy pattern. If you want a single configuration instance for your app, that's singleton. If you want to add logging without touching existing code, think decorator. These exercises help you build your instinct for recognizing patterns in the wild. To go further with design patterns, use tools that support visual thinking. Lucidchart and Draw.io are great for diagramming class structures and flows. Code editors like VS Code or IntelliJ help you implement and refactor patterns with ease. I also recommend two resources: the Design Patterns book by the Gang of Four, a must read, Refactoring.guru, an amazing interactive site that visually explains each pattern in multiple languages. Now it's your turn to practice. Pick two creational patterns, say singleton and factory, and implement them in your preferred language. Try to relate them to a real world problem. Also browse through an open source repository and see if you can spot any patterns. As a bonus, draw UML class diagrams of your implementations. This will help solidify your understanding. Let's wrap up. Today we learned that design patterns are not about complexity, they are about clarity. They give us a vocabulary to reason about design, solve common challenges, and write cleaner, more maintainable code. Remember the three code types: creational, how to create objects; structural, how to relate objects; behavioral, how objects communicate. The more you practice, the more natural patterns will feel. So keep coding, keep designing, and soon you will think in patterns.